So our focus question for today is, how can you find the distance between any 2 points on a plane? So it says here, in investigation 2, you found the lengths of tilted segments by drawing squares, finding their areas, and taking the square root. So we can also find lengths using the Pythagorean Theorem. So 2 questions that we're going to come back to at the very end. The first one is, how can you use the Pythagorean Theorem to find the distance between any 2 points on a dot grid? And then, how can you use the Pythagorean Theorem to find the legs of a right triangle with a hypotenuse of square root of 13? So we're going to be able to answer those 2 questions at the end. We're going to come back to that. All right, so here's your first task. Just hold on here. There we go. All right, so here's our grid. Now the question below says for part A, copy the points above onto dot paper. Well, you don't have to copy them because they're already on your worksheet. So lines KL is what we're looking for here. So that's why I got the yellow line on the dots K and L. So we're going to draw a right triangle with KL as its hypotenuse. So you're going to find me the lengths of the legs, and then using the Pythagorean Theorem, find me the length of KL. So I'm going to pause the video, and you guys are going to take about 5 minutes and see if you can find the length of KL with your people at your table. All right, so let's go ahead and do that. All right. So we could have drawn the right triangle in a couple different ways. We could have went this way. Right angle, or could have went that way. Either way is fine because you're going to have the same legs. So the leg here is 2. All right, this leg is 1, 2, 3, 4, 5. So if you find your 2 leg lengths, okay, we can use the Pythagorean Theorem. So the lengths are 2 and 5. So down here, we're going to use the Pythagorean Theorem to find C. 2 squared plus 5 squared equals C squared. 2 squared is? 2 squared is not 16. 2 squared is 4. 5 squared is 25. And C squared. So when I add 25 and 4 together, it's 29. And again, to isolate C, I want to square root both sides. And when I square root both sides, I get C equals the square root of 29. Or if you want to break the square root of 29 down, it's 5.4. So how many groups got 5.4? All right, good. So that's how we can use the Pythagorean Theorem to find the length of a line from one point to the other. All right. So on the back side, we got 2 lines here. All right. So again, in the same fashion, you guys are going to look for parts B and C here. You're going to find the distance from points M to N, and then P to Q. Again, using the same method that you did in part A. Okay. So again, we're going to pause this again and give you guys a few minutes to work on finding both distances now. All right. And then again, take your square root and break it down. Okay. Rounding to the nearest tenth. All right. So we're going to pause and go. All right. So, and again, understand that you can go either way. It doesn't matter as long as our legs form a right angle. And anytime we make a horizontal and a vertical line, they form right angles. So again, it doesn't matter. Okay? Because the same distance here is going to be the same distance here and vice versa. So this is 3, and that's 4, right? So if our 2 legs are 3 and 4, and we have to find the diagonal, all right, so 3 squared plus 4 squared equals C squared. And this is going to be very similar to the triangle we had in the notes yesterday, right? Where we colored in the squares and combined them. It's the same dimensions of the triangle. Because 3 squared is 9, 4 squared is 16, and 9 and 16 is 25. So when I square root both sides, let's square root 25. 5. This is the 3, 4, 5 triangle. Okay. For the PQ, and again, I'll just go the other direction. Since we went up, I'll go this way now. And again, a horizontal vertical line form a right angle. So here are my legs that we just drew. So 1, 2, 3, 4, 5, 6. Oop, and 3. So if our legs are at 6 and 3, 3 squared plus 6 squared equals c squared. And then 3 squared is 9. 6 squared is 36. Okay, 9 and 36 is 45. And then to isolate c, we're going to square root both sides. So we get the square root of 45. And if we want to break that down, we know that 7 squared is 49, right? So it's a little less than 7, 6.78, 6.7. How many people got 6.7? How many got 5? So pretty much everybody. All right, excellent. So again, that's how we can make right triangles to find the distance of a side. Now, here, remember way back in the very first investigation we did? We had that city of Euclid map, right? And we found driving distance, and we did all that stuff, going east and west and north and south. And then we threw the helicopter thing in, and we measured it, right, to see if it was different. All right. Well, here, it says you found the driving distance between the stadium at -2.3 and 1.8. What is the helicopter distance between the two locations? So again, the green line that we draw there is the straight line that we can go there, right? So basically, it says estimate the difference of the two distances. Well, if I make this right, this is either going east, north, or I can go up north and go east as well, right? So either way, it doesn't matter, but this has a distance of 3, and this has a distance of 5. So again, if I want to know the distance that we found from the helicopter distance, well, again, we can use the Pythagorean theorem to find that, right? 3 squared plus 5 squared equals c squared. Because again, these diagonals are hypotenuse. That's the missing side. Why don't you start writing that down instead of worrying about his ear? So 3 squared is 9. 5 squared is 25. And 9 and 25 is 34. So again, to isolate c, I'm going to square root both sides. So the square root of 34 is c. And again, if we want to break that down, I know that 6 squared is 36. So it's between 5 and 6, right? Closer to 6. 5 and 6. So 5.7, 5.8. You said 5.8. So 5.8. So again, that's the approximate distance of negative 2.3 to 1.8 is about 5.8 units. Just by using the Pythagorean theorem. All right, so we're going to try to put this all together with the last thing that we're going to do today. So it says, find the coordinates of 2 points that are the square root of 13 units apart. Okay, so to kind of get an idea what that is, right? If we were to put, I don't know, if I were to give you 2 points, one here and one, I don't know. So they basically want this distance to be the square root of 13. So think about the Pythagorean theorem, right? If c squared is basically c squared, they want to be 13. So c would be the square root of 13, right, when we square both sides. So what two legs, distance of the legs, would we be able to plug in there for us to come up with the square root of 13 as the hypotenuse? So what I'm going to ask you guys to do is take some time to talk with your group and see if we can kind of come up with the two legs, right? So if this distance here is the square root of 13, when I make my right triangle, what are the distances of these two legs for it to work? When I use the Pythagorean theorem to solve it. And when I use the Pythagorean theorem to solve it, this is what I got to come up with. All right? So I'm going to give you guys a few minutes to talk it over, see what you can come up with. And then we'll come together in just a few minutes and see what you did. So we're going to pause. All right. I know these two guys got it first. What did you guys come up with? What were the legs? 3 and 2. Everyone got 3 and 2. All right, how'd you come up with that? Someone want to share? Jack? Okay, so you knew 4 and 9 were 13. So how'd you come up with 2 and 3? Did you just take a wild guess, or what was your process, your thought process of how you came up with 2 and 3? You're right. A is 2 or 3, and B is the other one, right? So you just guessed. Did anyone use an actual different like a different thought process? Did anyone work backwards? All right, I'll show you that in just a second. All right, so just 2 and 3. You knew that the 3 by 5 was too big, right? So we had to go smaller, right? Anthony, what'd you guys do? Okay, so kind of like a little similar. Sounds like Jack's thought process, right? You knew that 9 plus 4 gives you 13, right? Right. So kind of in here, this would be your c squared, right? So when you get 13 equals c squared and square root it. Okay. Now it takes a little bit of work, but if you think about it, if you work backwards, right? These are kind of the bottom two steps over here. So if we try to work backwards to this, right? If I know that c equals the square root, I'm sorry, yeah, square root of 13. So the step above this would be c squared equals 13, right? Which means this would have to be, this is where Anthony goes to 9 plus 4, right? So up above here, this is where my squares are, right? Well, 9 is a perfect square of what? What's the perfect square of 9? 3, right? So this had to be 3 squared and 2 squared. So you could have kind of went backwards to find those as well. So in terms of trying to find the two coordinate, right? Explain how you know the distance between the points is the square root of 13. Well, because by Pythagorean theorem, we can solve it out. So if we were to put two coordinate points down, I mean, it doesn't matter what we put down. I mean, we could have hundreds of answers, right? If I start at 0, 1, which is right here, right? I would know I can go either over 2 or 3 and up the opposite distance, right? Because if I go, let's say if I go over 2 and up 3, right? There's my point. So when I drew my triangle, right, that's my leg, which means this would have to be the square root of 13. So I could have so many different possible coordinate points. 0, 1, and 1, 4. We could go, you could do this for hours, finding two different coordinates that have the same distance between their hypotenuse, because you just find that 2 by 3 dimension of the right triangle. We could come up with so many different answers. All right, so going back to the front to answer those two questions that we talked about in the very beginning. I don't know why that's there. So, how can you use the Pythagorean theorem to find the distance between any 2 points on a dot grid? So again, if you were given a graph, and I give you this point and this point with a line, how can we use the Pythagorean theorem to find that distance? What did we do? Someone said it. Make a right triangle, right? So we draw a right triangle. And then we solve, right? Because once we go about drawing our right triangle, we can go ahead and solve it, right? That's how we did it. We had to come up with the two legs. So we can find the distance between the 2 points, which is always the hypotenuse, or at least in these cases it was, right? I mean, if they gave us a vertical line as the distance, we could draw, the right triangle. We'd be finding a leg, or we could just count the dots. All right, now second question dealt with the very last question we did. So how can you use the Pythagorean theorem to find the legs of a right triangle with a hypotenuse of 13? And what a few of them said was that they were looking for the two legs that added up to 13, right? So they were trying to find two perfect squares that add up to 13, okay, which happened to be 4 and 9. You could also work backwards, right? You could also try to work backwards from the answer. Okay. Again, you had to know that the sum of the two squares of the legs had to be 13 because C was the square root of 13. So these two legs had to add up to 13, A and B. And again, they had to be squared to add up to 13. 2 and 3 doesn't add up to 13, but 2 squared and 3 squared does. Okay? And that's how we found that. All right, so that's going to take care of the video.